guys ever notice the unique pattern in nature, like the number of petals on a flower or the spiral on a seashell?
Yeah.
You may think it's just a coincidence or part of nature aesthetics, but turn out it has close connection with mathematics. Now try imagine. What if a simple sequence of numbers could really explain all those natural wonders? Sounds what, right? But it's get even better. This pattern doesn't just pop up in the nature, you know. You will find it in art, music, and even the unpredictable world of stock market charts. So, what's the secret behind this perfectly balanced pattern in the world around us? Well, all roads lead to one legendary name in math history. Yup, Fibonacci. We are talking about the famous Fibonacci sequence. In this little journey, you will see how math isn't just about putting equations on a paper, but it's a hidden language that helps us understand the beauty and structure of the world we live in.
Oh, yeah, yeah. But do you know the one scientist that discovered Fibonacci?
No?
Yeah. If you don't know, his name is Leonardo da Pisa.
Yeah, Leonardo da Pisa or Fibonacci is a scientist that also known as mathematician that was born in Italy in 1120 and died in 1250. In Italy, he was raised and surrounded by a lot of Muslim scientist community and he learned a lot of mathematics from them back then. Well, in 1202, he made a book that called Liber Abaci. In this book, Leonardo da Pisa or Fibonacci explained the advantage of Hindu-Arabic numbers and introduces various methods of calculation that are very useful in trade and everyday life. This book was very influential in spreading the modern numeral system in Europe and also influences in the finance and also introduced us about the famous Fibonacci sequence that can form a golden ratio that has the number are 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and etc. Interesting, right?
Oh, I heard also about that, but do you know, guys, the early history of the Fibonacci or the development from time to time?
No,
Not yet.
not yet.
The history of the Fibonacci sequence actually traces back to India. Around the year of 1150, an Indian mathematician named Gopala, later followed by Hemachandra, described a numerical pattern through a problem involving the probability of placing items into a bag. A few decades later, this pattern was introduced to the Europe by Fibonacci. In the year of 1202, he wrote a famous book called Liber Abaci. One of the examples in this book described the growth of a rabbit population. Believe it or not, the famous Fibonacci sequence starts with rabbits. Here is the idea. Imagine you have one pair of rabbits. Each pair can reproduce every month, but only after they are 1 month old. In the first month, they are still too young, so only one pair. Second month, the first pair give birth to a new pair. Now, there are 2 pairs. Third month, the new pair is still too young, but the original pair reproduces again. Now you have 3 pairs. Each month, the number of rabbit pairs equals the sum of the previous 2 months. So that's the Fibonacci sequence. Not only this concept, but Liber Abaci also introduced Indo-Arabic numerals to Europe by introducing the digits 0 through 9 and the decimal system. Fibonacci helped transform mathematics in the Western world. In addition, Fibonacci numbers are deeply connected to other areas of mathematics. They are used in Euclid algorithm, the Pascal triangle, and even the Zenker-Dove theorem. Shows that every positive number can be uniquely represented as the sum of non-consecutive Fibonacci numbers. From time to time, there is any development and there is an application not only in mathematics, but there are some application in science and technology. In the world of science, take a look at the sunflower. It's seed from spirals that follow Fibonacci numbers, like 34 and 55. Nature used this pattern to optimize space and growth. In the technology, Fibonacci is used in trading. The Fibonacci retracement method helps traders predict when prices might rise or fall, using ratio like 0,382 and 0,618 from the Fibonacci sequence.
But do you know that Fibonacci sequence is really unique?
Yeah, I guess.
Fibonacci isn't just any random string of number. It's truly special. Even today, people still study it and use it in all sorts of fields. Here, why this number pattern is so awesome. First off, it's everywhere in the nature, seriously. Like I said before, you will see it in how plants grow, the number of petals on flowers, the spiral on a leaf and panicles, and the shape of seashells, and even in the swirling arms of galaxies. It's like math is woven right into the fabric of the universe, not just some human invention. Second, the Fibonacci sequence is closely tied to the golden ratio, that famous 1.618 number. If you divide two consecutive Fibonacci numbers, you will get something that gets closer and closer to the golden ratio. This ratio shows up in the art, architecture, and design because people find it naturally pleasing to the eye. So it's basically nature's favorite blueprint. Third, it's super versatile and used across many disciplines. In finance, for example, Fibonacci retracement is a popular tool to predict where prices might bounce or reverse in stock trading. In computer science, the sequence pop-ups in recursion, efficient algorithm, and even in fancy data structure like Fibonacci heaps. Fourth, it's a great way to learn math. The Fibonacci sequence helps students explore patterns, recursion, logic, and problem solving in a fun and meaningful way. It is a perfect teaching tool that makes math feel less abstract and more connected to real life. And finally, there is some kind of deep and philosophical about it. The Fibonacci sequence shows us that even in chaos of nature, there's often an underlying order. It's like a gentle reminder that math is quietly organizing the world around us. So yeah, Fibonacci isn't just a bunch of numbers. It's a symbol of how much nature, art, and technology are all connected.
Oh, yeah, that's interesting. But do we realize that in the future we will gonna be a teacher?
Yeah, kinda.
So actually, do you know about the way we teach the students about Fibonacci?
Nah.
Yeah, I heard about the model or the approach that can be used to teach Fibonacci to students.
So, learning with Fibonacci sequence material can be done meaningfully by integrating contextual approach and collaborating it with problem-based learning or discovery learning models. This can help students not only understand the concept formally, but also realize in relationship and application in everyday life. The first is contextual approach. Contextual approach is an approach that also can be known as educational process to help students understand the meaning of the educational material they learn by linking it into the context of their daily life, namely the environmental context, individual, social, and cultural. For example, students can observe Fibonacci sequence from flower patterns or the golden ratio that can be from seashells. That's a lot of them, and also from the astronomical objects like stars and galaxies. Now move into the problem-based learning. Problem-based learning is a learning model where students are faced with real-life problems which are then used as a trigger for learning. There are several steps or known as a syntax in problem-based learning. First is orient students to the problem, organizing students learn and create activities by individual or groups, presentation of knowledge of result, and the last is analysis and evaluation of knowledge of thoughts. In its application, according by the syntax, students can be grouped into several groups or individual and asked to explore objects around the school or through digital media. They are given direction to collect data, analyze, and try to formulate so as to solve the given problems. It's interesting, right? Now let's move into the next model that can be applied is discovery learning model. Discovery learning is a learning model that is the understanding of concepts, meanings, and relationships through an intuitive process to eventually arrive at conclusion. Discovery occurs when individuals engage primarily in the use of their mental processes to discover some concepts and principles. Like problem-based learning, there are several steps or syntax that can be implemented when we use discovery learning. The syntax are first is giving students stimulus, second is problem identification, the third is data collection, fourth is data processing, and then students must be proving and generalization. If you use discovery learning, the learning is designed so that students actively discover the Fibonacci pattern themselves. Like, students can be invited to connect it with visual forms such as Fibonacci triangles or spirals and even associate it with the golden ratio. The discovery process builds a deeper conceptual understanding because students experience the mathematical thinking process themselves. These two models are very much in line with the contextual approach as students are trying to see the connection between math and the real world. Then, learning Fibonacci sequence is not just a matter of counting, but a bridge to understanding the beauty and how to implement mathematics in daily life. So, you can try it.
Oh, sorry guys. I have another thing to do. So, if you excuse me, I can. Can I go first?
Yeah.
It's okay.
Okay.
I'm going first, guys. Thank you.
Bye. Yeah. If you don't know, his name is the Lisa.